Have you ever wondered about AI? I mean, it can write perfect legal contracts, sometimes,
Mm-hmm.
but then it completely misses the point of a simple joke. It's weird, right?
It is. There's been this fundamental split in AI for decades.
Exactly.
Yeah.
And, well, what if we could actually bridge that gap? Create AI that doesn't just, crunch data, but actually gets it.
That's the nuance.
Right. So today, we're doing a deep dive into something called Sophimatics. It's this really interesting approach using hybrid symbolic connectionist logic in AI.
Mm-hmm. And our mission here really is to unpack how combining these two, well, historically separate AI philosophies, how that combination can lead to systems with, frankly, incredibly boosted interpretative skills.
So closer to AI that understands the world more like we do.
That's the goal, something that grasps the subtleties.
Okay, that idea of like genuinely smart machines. Machines that go beyond just matching patterns. That's why this analysis from Gerardo Iovana and Giovanni Iovana on the logical mathematical layer in Sophimatics feels so important.
It really is key.
Yeah.
And they build on some fascinating work from others, too.
Yeah, people like Vermter and Leonard, Rowley et al., Rose, Lage, Rangarajan et al. It seems like a really rich area.
Yeah.
This should give us some real aha moments, I think.
Definitely. There's a lot to dig into.
So for anyone who's kind of followed the AI story, you'll know about this big divide. On one side, you've got symbolic AI, all explicit rules, clear logic.
Very structured.
Yeah, the meticulous planner type, right? Brilliant for things needing traceable steps, like understanding legal text or strict grammar. It's good at manipulating symbols, drawing clear conclusions, very hierarchical, easy for us humans to follow along.
And then the other side? Connectionist AI. That's your neural networks territory.
Right.
Known for learning, for generalizing, figuring out complex, often kind of fuzzy patterns. It's great with distributed information, ambiguous stuff, things it hasn't seen before. Really adaptable for complex sense-making.
Like recognizing your face even if you're wearing a hat.
Exactly. It's more like the intuitive artist, maybe, compared to the symbolic planner.
Okay, so it sounds like two, I don't know, brilliant but really stubborn siblings, each thinking their way is the only way.
Huh. That's not a bad analogy, actually.
But, siblings can work together sometimes. So with these powerful but really different approaches, can they actually be reconciled? Or are we just stuck with AI that's good at rules or patterns, but, never really both?
Well, that's exactly what Sophimatics tackles head on. It's really designed as a way to reconcile this split.
Okay.
The whole idea is to harness the best of both worlds, get the advantages of symbolic and connectionist AI, while crucially overcoming their individual drawbacks. You mentioned Vermter and Leonard, Rowley et al. They were pioneers looking into this back in '89 and '95.
Right, showing it could actually work.
Showing the power of going hybrid, yeah.
So let's really get into how this hybridization works. How does it become more than just adding two things together?
Well, you start with the symbolic parts. They provide that explicit structure, the hierarchy, that gives you clarity, precision, really important for high-level abstraction. It's like the skeleton.
A solid framework. Okay.
And then complementing that perfectly, you have the connectionist elements. They handle the distributed information, capture those tricky, ambiguous patterns symbolic systems often miss, and they generalize really well.
So they handle the messiness of the real world.
You could say that. And putting them together makes the whole system much more robust and accurate, especially when dealing with unpredictable data.
Okay, I think you mentioned an example from Vermter and Leonard earlier.
Yes, exactly. Back in '89, their system used the connectionist network to figure out context, to disambiguate meanings, pick the right sense of a word.
The subtle stuff.
Right. While the symbolic part handled the strict grammar rules. And the result, a system that could do things neither part could manage alone. Real synergy.
That really drives home the benefit. So it's not just theoretical. These hybrid systems actually perform better.
Oh, demonstrably so. Especially in things like image recognition experiments. They've consistently outperformed purely symbolic systems and purely connectionist ones.
In what way? Like accuracy.
Accuracy, precision, coverage, both for things they've seen before and for completely new linguistic constructions, which is a big deal.
Okay, that's impressive. But how does a structured symbolic model actually help a neural network? They seem so different in how they operate.
That's a great question. Essentially, the symbolic model provides a kind of initial structure or set of constraints.
Like guardrails?
Sort of, yeah. It gives the neural network a clearer starting point, a better direction for processing information. This actually makes the learning much more efficient,
Okay.
and it really boosts the network's ability to generalize to new data it hasn't encountered, which is often a major challenge for AI.
Got it. So it helps focus the learning.
Precisely. And Rolly et al. In 95, they found something similar with image recognition. If you give the system symbolic concepts like this is a cat or the ball is on the table, that extra information.
That's structured context.
Right. That helps improve the system's overall output quality and accuracy. It's about feeding that intuitive learning process with some high-level explicit understanding.
Okay, this makes sense. But let's talk about something trickier. These open textured concepts. That sounds vague.
Well, they are vague, or at least flexible. Think about concepts like reasonable care in law, or even just fairness in everyday life. Their meaning depends so much on context, sometimes even subjective judgment.
Okay, yeah. Hard to pin down with just rules.
Exactly. Rigid symbolic rules aren't flexible enough. But purely statistical patterns from connectionist systems, they don't quite capture the meaning or the human interpretability either. They struggle with that open texture.
So neither side alone can really handle that ambiguity well.
Not optimally, no. And this is where the hybrid approach really shines. It offers what we call interpretive flexibility.
Interpretive flexibility, meaning?
Meaning it allows for concepts that are understandable to humans, like symbolic ones, but also connections that can adapt dynamically as the context shifts. It's much closer to how we navigate these nuanced ideas.
Is there a good real-world example of this?
Absolutely. Rose's Stellier system, back in 1994, is a classic one. It used both symbolic and connectionist methods to analyze legal documents.
Ah, the law again. Good test case for ambiguity.
Definitely. What's fascinating about Stellier is how it tries to capture both the fixed rules you find in law and that interpretive skill a good judge or even a law student develops.
So it acknowledges that law isn't just static rules.
Exactly. Rose argued that the legal system actually operates through interpretation, and judges can and do change how rules are applied over time. Stellier tries to model that dynamic aspect.
How did you do that? What were the components?
It used symbolic reasoning to pull out the core conceptual structures from past cases, the precedents. But then it used connectionist learning to build conceptual structures for future cases that could change and adapt.
Dynamically changeable.
Okay. And critically, it included interactions with a human user to help guide those changes. It really tried to mirror how a legal professional's understanding evolves.
That's really sophisticated.
Yeah.
So, okay, we see the high-level benefit. But how does this work mechanically? Let's look, under the hood a bit. You mentioned a 3-level network.
Yes, a key architectural idea often used in these hybrid systems is a 3-level connectionist network. Let's break it down.
Okay, level 1.
The lowest level, this is all about raw perception, the initial input. It uses distributed connectionist representations, think neural nets processing raw signals. It forms what the source calls microfeatures.
Microfeatures,
Like individual phones from speech or pixels from an image, the most basic sensory bits. Lange talked about this in 92.
got it. Raw data in. What's level 2, the middle?
Middle layer. This takes those microfeatures and starts to group them. It uses more localized connectionist methods, clustering, to represent intermediate patterns or objects. The source calls them microconcepts.
Microconcepts. So maybe recognizing vowels or consonants or simple shapes, colors.
Exactly. Grouping the basic bits into slightly more meaningful units, letters, maybe simple shapes, that kind of thing.
Okay, makes sense. Raw bits, then basic units. What about the top?
The top level, this is where the real abstraction and generalization kick in. It often uses something like marker passing network models. These represent the micro-concepts from the middle layer using more localist conceptual representations.
Maybe.
Meaning it allows the system to draw higher level, more symbolic conclusions. It's building structured knowledge from those lower level patterns and units.
Ah, I see. But the key thing is these layers don't just operate one after the other, right? They work together.
Absolutely crucial point. They're not isolated silos. They constantly combine their knowledge, feeding information up and down to create a much richer, more comprehensive understanding of whatever's coming in.
Can you give an example? Like for language?
Sure. Lowest level might recognize the raw sounds, the phonemes. Middle level groups them into morphemes, like prefixes or word roots. Then the top level might categorize the whole word, noun, verb, etc., and understand its grammatical role, all working together.
So it builds up understanding layer by layer, but integrated.
Precisely. Or think about recognizing a scene. Lowest level sees edges, corners. Middle level identifies objects, the chair, a table. Top level understands it's a dining room.
Okay.
And it's this kind of integrated hierarchical processing that makes Sophimatics so powerful for complex tasks, natural language, machine translation, scene analysis, you name it. It mimics how we build understanding.
This is fascinating. We've talked structure, adaptability.
Yeah.
But what about the human side? Feeling, intuition. Can AI ever really get the why behind something, not just the what?
That's pushing into really deep territory.
Yeah, this idea of adding affective quality and qualitative resonance. What does that even mean for an AI? And why is it important for rich sense-making?
Well, think about real-world decisions. Often qualitative data, someone's experience, how they feel is essential.
Like in medicine.
Exactly. In a critical medical situation, knowing what the patient is subjectively experiencing can be just as vital, maybe more so, than just the raw numbers on a monitor. It's about that lived reality.
Okay, I get that for humans. But how does that apply to machine learning? How can a machine use experience?
Rangarajan and colleagues in 2022 explored this. They suggest that providing experiential context, maybe like applying subjective weights to certain words or images based on past interactions or human feedback.
So telling the AI, this concept is more important, or this image feels negative.
Something like that, yes. It gives the computer a way to assess the significance or the valence of a pattern within its current context. Not just recognizing the pattern, but understanding its weight, its meaning in this situation.
Wow. So moving beyond just recognition to evaluation.
In a sense, yes. And connecting this back to the big picture, adding this affective or experiential component helps AI systems get closer to approximating phenomenological reality.
Phenomenological reality, how humans experience things.
Basically, yes. Look, the ultimate aim of AI, arguably, is to tackle tasks that need human-level intelligence or knowledge or even wisdom, but maybe do them faster or more effectively. This experiential piece fills a huge gap in getting there.
So if you give these already powerful symbolic connectionist systems this experiential layer, they can start to output things that approximate subjective human experience.
That's the idea. Not that they feel it, of course, but that their processing and output can reflect an understanding of subjective significance, like understanding not just the logic of an argument, but maybe the emotional weight behind it.
Okay, that makes affective quality sound less like a weird add-on and more fundamental.
I think it is. It's crucial, really indispensable to the whole Sophimatics vision. It's what elevates it towards being, as the source puts it, the science of computational wisdom.
Computational wisdom.
Yeah.
That's a powerful phrase. So just to recap this whole deep dive then, Sophimatics isn't just aiming to make AI technically smarter.
No, it's much deeper than that.
It's about making AI understand in a way that actually connects better with human experience, with context, with meaning. It feels like a genuine shortcut to getting it up to speed on where AI might be heading.
I think so. It represents a significant shift in thinking.
So here's something to maybe leave you, our listener, thinking about. If AI systems can now start weaving together complex context, if they can learn adaptively through interaction, and even begin to factor in affective quality.
What does that actually imply for our definition of intelligence itself? Where do we draw the line? And maybe more excitingly, what new possibilities does this quest for computational wisdom open up for AI's future and, well, for its impact on all of our lives? What stands out to you from everything we've unpacked today?